This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers, retirees, students, and other not-so-nefarious characters who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will fabricate and install the breadboard prototyping matrix and remove the foam-based double-sided stickum goo from behind the strips. This time I did it with WD-40, which was a lot easier. The oil prevented the goo to stick to anything and facilitated the process. The goo was dissolved by the petroleum base of WD-40. And now I'm marking off a portion of the fiberglass epoxy to serve as a backing plate for the prototyping matrix. Now I'm about to try to cut the epoxy fiberglass with this Dremel saw. I've got the Dremel saw hooked into a foot switch. Now it's cutting very nicely. This is exactly what I would like to see in a saw, cutting a piece of printed circuit board. And lo and behold, it starts veering off to the left. And I can't quite get it to return. Now I'm going to try, I've reconnected the saw blade. Let me see if I can just finish up the cut. And I can't. It veered off and it won't return, it won't scroll back. This is disappointing. I mean, really, this saw is exactly what I would have liked to be using, and it doesn't work. And I kind of question how the company could have released this. Well, let me try once more. I'm going to attach the saw blade. Now it's attached. I'm going to put the epoxy fiberglass down, and got the cover down, and now we're going to start sawing. Let's see what happens this time. It looks like it's working. It looks like it's going well. It looks like it's veering off to the left, and I can't get it to return. Now, I don't understand how the company could release a piece of bleach like this, and we're now going to hacksaw our way to cut the remainder of this. I still have to correct the damage done by the Dremel so-called scrolling so-called saw. So let me clamp this board down, and this time I'm going to use a rotary tool. We'll take this rotary tool with a cutting wheel and finish off the cut. This cuts fairly well and quickly, but it's difficult to control. Alright, and we do it. Sort of, kind of, almost. There you go. Okay, now let's just disconnect this, and now there's a lot of damage done to the edges by the Dremel so-called scrolling so-called saw, which I now want to try to file flat, and I won't subject you to endless minutes, if not hours, of filing. But it did take some time, a little more time than you see on this particular video. And finally, I got the piece relatively well squared off, good enough to suit its purposes. I'm making an awful lot of use of this particular flat file of late. And now I can take a look at this. It matches the solderless breadboard matrix. Considering what the saw did to me, this is a fairly good job. Having removed the double-sided stickum goo from the combined solderless breadboard sockets, I now need to clean those sockets. I'm using 99% isopropyl alcohol, and go scrubbing this in. I need it to be clean, and I need to get any fiber, any foam particles out of there. Once I have cleaned off, I'm also looking to get the grease off of the board, any fingerprints I may have left there, any kind of dirt that adheres to it, because once I start gluing, I don't need any bumps and garbage in between the glued socket. I'm using a 5-minute epoxy glue that just mixing together and applying as quickly as possible. The 5 minutes means that after 5 minutes you can't really work it. It doesn't mean that it is set or gotten to any kind of usable consistency, other than you cannot work it after 5 minutes. And so I'm kind of rushing through this. I want to have a fairly uniform coat of this. Now if I have time, I'm going to try to coat one side of the epoxy fiberglass board as well, but I'm running out of time. This video is double speed, and my 5 minutes is rapidly approaching an end. Okay, I'm just going to put this board down. I've cleaned that side of the board facing the sockets, and now I'm going to clean the top side of that board with isopropyl alcohol as well. Now I'm going to put this board on a Panavice base because it's flat. It's probably the flattest thing I have around. I don't have a granite block around here. I need it flat so that I can apply uniform pressure to the backing plate, and to keep that pressure on for some period of time, you need to put a heavy weight on it, like, say, a Webster's Unabridged Dictionary. And 24 hours later, the glue's set and the adhesion appears to be good. So now I'm going to start laying out guidelines for attaching Velcro to the backing board, as indicated from this printed off piece of the layout. Using a fine-pointed Sharpie. I suppose the tool of choice would be a scribing tool, but I don't see the point. Now I'm going to put the Velcro down to form, I guess, isosceles triangles. I've done some experimenting with this, and I think this is the best configuration. It allows you to lift the boards out without undue effort, and it also permits a fairly solid base once the Velcro is attached to the enclosure. I'm attaching hooks to the board. Now I need to press this down, make sure we have good adhesion of the Velcro to the epoxy fiberglass. And now I'm going to put the loop piece in. Now this is the loop piece and cut to the same size. And by attaching the Velcro in this manner, it makes life much easier when I go to attach these loops to the enclosure. One more go at this with a board to press these things together, and now remove the protective strip, exposing the adhesive of the Velcro loop piece. And this is another one of these things that's a little more difficult than one might think. Okay, now what I need to do is to very gently and gingerly line this thing up and slowly put it down. I need a little bit of space between the matrix board and the power distribution strips. And now here I'm going to put another heavy weight. Webster's is awfully useful. Now, in addition to the 4 strips on the corner, I'm going to put another 3 strips here to accommodate single IC strips and the smaller IC strip. So I'm going to add some more Velcro loops to the top panel of the enclosure. And this would allow me to have a single IC strip tacked down to the enclosure and a single mini IC strip, the kind of stuff that there you go, and a single strip like this, which I use for Arduino prototype boards. In this video, I constructed an unclad FR4 backing board despite problems caused by a Dremel scrolling saw, glued the backing board to the breadboard socket matrix after removing the foam-based double-sided stickum goo, attached self-adhesive Velcro to the back of the breadboard socket matrix and to the enclosure front panel. In the next video, we'll be installing some power transistor sockets to be used in prototyping the prototyping system. Yes, I know, that's what I said. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. It's not all that difficult, and I promise to read it. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, vector graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.